Okay, so this portion will go over the algebra of we got partial fractions set up, but how do you find these a, b's, and c's? So going all the way back to the first example we did. All right, we had it set up. We set the numerators equal, but now we need to figure out how to solve for a, b, and c. And there are a couple of main ways you do that. One way would be to take a look. You don't have to highlight this right now. I'm going to get rid of it in a second. But to take a look at this, FOIL it all, distribute it all, get it all cleaned up, and then compare the x squared term on this side with the x squared term on this side. Compare the x term and the x term and find your coefficients that way. That usually is not the fastest in a setup like this one. So usually when you're going through and trying to find A, B, and C, way one of doing that is what I'm going to say is zeroing out the factors with your choices of x. Meaning, first, I would take a look and say, I see this x plus 1 as a factor, so I'm going to let x equal -1, because -1 plus 1 would cause it to go to 0. That would turn my equation, if x is -1, into 5, well, -1 squared is still 1, minus 20, because 20 times -1 would be -20, plus 6 equals, well, it would zero out the whole a term because you would zero out that factor. It would then also zero out the entire b term, and so you would be left with -c, because c times -1 would be -c. So you are picking an x, and then you are coming back up here and plugging it in and seeing what you come up with. So if I just add up the numbers on the left, I'm at -9 equals -c. So that's how I get 9 as c. Okay. So you're going back through and you're going to replace every x you see with the x that you have selected. And the smart ones to select are ones that will zero out the factors you're seeing on the right-hand side. So then when I go to do this again, I zeroed out the x plus 1. I also have a factor of x. I could zero it out, so I could let x equal 0. Then the whole left side would turn into just 6 now, because everything with an x would zero out. Then I would have a times 1, because 0 plus 1 is 1, 1 squared is 1. Then I would zero out my b's, and I would zero out my c's, because they each had the x on its own. So that's how I can figure out that a is 6. But then I'm kind of stuck, because my factors were the x plus 1, which I've already zeroed out, the x, and then the x plus 1 repeating, but I've still already zeroed that part out. So I can't really use that strategy anymore, but I have to figure out what b is. I could take the a and the c and plug them in up here and distribute what's left and set things equal. But I could also just pick an easy x, and that's what I'm going to do. So pick an easy x that you want to work with and plug in. I'm going to say x is 1 and go plug that in. So again, this is my equation I'm plugging into for all the x's. So that would turn into what? 5 for that first part. And then if I plug in 1, I would get 20 for the second part, 6 for my coefficient. Then I would have 6 times, because I've already figured out what a is, so I can use it, times x plus 1 quantity squared. So I chose 1. 1 plus 1 is 2, and 2 squared is 4. Then plus, I'm trying to figure out b, so I don't know what it is. X I selected as 1. So that I don't need to write. Multiplying by 1 doesn't change anything. But here, x I selected as 1. 1 plus 1 is 2. Plus my c value. Oops, I don't want that. Go away. Plus my c value. Sorry. Goodness sakes. There we go. Plus my c value is 9, and then my x that I picked was 1. So plus 9 times 1. Okay, so I have 31 on my left side, and then I have 4 and 6, 24, plus 9, 33, plus 2b. And then I can solve. So I should get negative 1 for b. Okay. So pick an easy x, and you might want to put in and plug in your, in this case, a and c. But if you had already found like a and b, whatever you've already found, you can plug that in and use all of that information to help you find the missing piece. So that's one algebra strategy for how you can take this equation and solve it decently quickly. I mean, it still takes a while and it takes some practice for you to get the hang of it, but you zero out the factors that you see. So we zeroed out the x plus 1, we zeroed out the x. You plug in and set those things equal to find like a's and b's along the way. And then when you're stuck on that last part that you need to find, you pick something that's easy to work with and plug that in. You also plug in the other values you've already found. So that's the algebra piece for how we find our constants on the first example. And then if you go to the second example, this is still a good strategy, and so I'll show you that. If we're going to pick out our x's, solve for a, b, c, and d, and we're going to use the method of picking convenient x's. So one thing that is going to zero out factors that I see up here is if x is 1. So if x is 1, and again, you're just going through and replacing every x you see with what you're picking, in our case 1. Put every x all the way throughout here. And we have a lot of them on this one. All right, so I would get 2 minus 4 minus 8 on the left side. And then I would have zeroed out the first term entirely because I zero out the x minus 1 factor. But the second term with the b, I'm going to have some stuff. So if x is 1, b times 1 times 1 plus 4, or 5. Plus, and then a 0 again because it has an x minus 1 factor for that last part. Okay, so negative 4, negative 8 is negative 12 plus 2, so negative 10 is 5b. So negative 2 is b. All right, another choice that's easy to zero out would be this x that's on its own. Let's pick x equals 0. And again, go back up there. Well, if x equals 0, the only thing left on the left side is negative 8. If x equals 0, though, I have a first term to worry about, but it's going to zero out the second term. It's going to zero out the last term because they have plain x's in them. But first term, I'm going to have a times 0 minus 1, so negative 1. 0 squared is still 0, but plus 4. So I see that negative 8 equals negative 4a. Divide by negative 4, 2 equals a. Okay. Third thing, let's see what I can zero out. I have another factor. I have this x squared plus 4 factor, but I can't zero it out because it's a sum of squares, not a difference of squares. The only way I could zero it out is with imaginary numbers, and that's not going to help me here. So All right, then that means I just have to pick convenient x's that I want to work with. Well, I've already used up 1 and 0. Those would always be my top two choices. So picking something else, maybe let's go -1. So if I want to pick x equals -1 and plug into the left side, I end up with -2, +4, -8. If I want to plug into the right side, so 2, because I already know what A is. Again, you're going and replacing everything that you already know. I'm going to put in the 2 for A, and then I'm going to choose, so I picked -1, so -1 minus 1, and keep going. So -1 minus 1 is -2. And then if I take -1 and square it, I get 1. If I add 4 to it, I get 5. Then I also already found B, so plus a -2 for B, the -1 that I'm picking for x, and then 5 from that quadratic factor, plus parentheses cx, so c times -1, plus d, because I don't know what that is either, times the -1 I picked for x, times, can't tell anymore, x minus 1. Okay, so -1 minus 1, so -2. Okay, so I'm getting -6 equals -20 from that first part, plus 10 from that second part, and then I have plus d minus c times 2, so -6 equals -10, plus 2d minus 2c. Then I would add the 10 over, so I get 4 equals 2d minus 2c. I would divide all of those terms by 2 just because it happens to be a common factor. If you don't have any common factors, you'd be done, but 2 has to equal d minus c. Okay, then that's still not enough though. I have two things I'm trying to solve for. So I picked an easy x to work with -1. I've already used -1 and +1. I've already used 0. So another choice of something that's easy to work with would be 2. And if you do that, and again, go back up to this equation, and every x that you see, you now put in a +2. You fill in the a that we solved for with 2, and you fill in the b that we solved for with -2, and you do all that cleanup. You should be coming up with 16 equals 2d plus 4c. Well, this makes a 2 by 2, and you either substitute or eliminate to solve. I think I still had some room on the next page. You might as well. Like, I don't know if our calculus took us, yeah, it didn't take us the whole page, but the algebra on this one is taking quite some time. I will also attach another document. I'm not going to make a video, but I have worked out, there are two methods that you can use to find A, B, C, and D, and I have worked each example in the opposite way from what I'm doing on the video. So I will scan that in if you want to compare the other technique to find A, B, C, and D, but it's not great either. This problem just takes a while. Okay, so you would end up coming up with C is 2 and D is 4. And again, you can either solve the system with substitution or you can solve the system with elimination. It's totally your preference. All right, next example. The algebra on that one to find A, B, C, and D, since they are all quadratic factors that I worked with. Well, if these are all the quadratic factors, usually plugging in isn't as helpful. Or isn't as efficient. Okay. So this is going to be done with what I'm going to call way 2. And way 2 is matching degrees and coefficients. All right. So what I mean by that is going back up here to this equation and distributing, foiling, whatever I need to do on the right-hand side. So on the left-hand side, I have 8x cubed plus 13x. But on the right-hand side, getting that cleaned up. So I start foiling. So I get ax squared plus 2ax plus bx squared plus 2b. So you're foiling this whole first set that you see. And then sometimes you will have several other things that you're foiling as well. But I don't here, I just have to add cx plus d. Oops, it didn't switch over, hang on. Switch back to the pen. Plus cx plus d. Okay, now I want to combine like terms. So I want to take a look at the things that involve x squareds if there are several. Well, there are. This has an x squared. This has an x squared. Then I want to take a look at things that involve x, so the 2ax and the cx. And then I want to take a look at my constants. Oops, I did that again. At my constants that I have. So things that don't have x's with them. All right, so I have 8x cubed plus 13x, and then that is really equal if I take a look at my x squareds and I factor out the x squared. I would have a plus b quantity and then x squared. Okay. Oops, hang on. I didn't FOIL correctly, which is what happens when I don't scroll up and look at it. The x times the x squared is x cubed. So hang on. That's not going to be a true statement. All right, ax cubed. Let's fix that. And let's also fix this. So the x cubed is on its own, the x squared is on its own, but the x's and the constants go together. Okay, so I have ax cubed, and then I have bx squared, but then I have plus, switch over, and then I factor out the x's. I have 2a plus c in parentheses, all of that times x. And then I have plus the 2b plus d. Okay, so the 2a plus c is going to get matched up with the 13. Then everything else gets matched up, but sometimes it gets matched up with zeros. So let me pick out another color for a second. So this ax cubed gets matched up with an 8x cubed. So I know that 8 has to equal a. Well, there were no x squareds. Well, okay, so there were no x squareds over here. So that means that's the equivalent of plus 0 x squared. So if I try to match that up, that means that 0 is equal to b. Okay, then if I try to match up for my x's, I'm going to set negative 13 equal to 2a plus c. And I'm going to have to solve that. Oops, hang on. Was it negative or positive? I kind of covered it up when I made my circle. Oops, positive. Positive 13. Okay, and then I also don't have any constants at the end, but that means I could also write at the end plus 0 if I need to. So I'm going to match up that I have that 0 equal to 2b plus d. With all four of those pieces of information, I can find A and B and C and D because I've already found some of them. So for if A was 8, then over here where I see A, I can plug in 8. And if B was 0, then here where I see B, I can plug in 0. And that can help me find things along the way. So 13 equals 2 times 8 plus C. So if I subtract the 16 over, I come up with C equals negative 3. And then if I zero out the B, then that also happens to give me a 0 for D in this case. So now I have all of them. I have A and B and C and D. A, B, C, and D. You are welcome to try way 1 or way 2 on any question. Typically, it is easier if when you see that you have all the quadratic factors, so the ax plus b's and the cx plus d's over and over, then that is typically faster to go ahead and distribute all of that or FOIL however many times you need to and match up the coefficients. And then it is typically easier when you have just all these factors that you can easily zero out. It's typically easier to do that to find your A's and B's and C's. But, like I said, look for the document that shows example 1 worked the other way and example 2 and 3. And you can compare and see what you would prefer. And you can try whichever one you want as you're doing homework. Okay? You just need a way to be able to tell what A and B and C are. It doesn't all have to be the same way, and you don't have to show some big elaborate algebra process if you're able to figure it out. All right. Last thing would be just that there was a multiple choice for you to try at the end. So I'll do a real short video on it, and you can check your solution if you need to.